Good day, everybody. Today we are going to discuss chi-square hypothesis test, okay, or hypothesis test for standard population standard deviation. So scores on an IQ test are normally distributed. A sample of 25 IQ scores at standard deviation S is equal to 8. The developers of the test claims that the population standard deviation is sigma equal to 15. Do the sample data provide enough evidence to contradict this claim? Okay. So first we will write the null hypothesis H sub 0 is equal to sigma is equal to 15. Now, that's what the developer claims. So the alternate hypothesis, since we do not know whether it is greater than or not or less than, it definitely differs from or not equal to 15. Okay. My sample size n is equal to 25. So my degrees of freedom is n minus 1, which is 25 minus 1 is 24. Alpha level of significance is 0.05. Okay, so this is the maximum probability of making a type 1 error. Okay. So first, we should calculate alpha by 2 is 0.05 divided by 2, which is 0.025. So if I create some space, moving this slightly up. Okay. So this is of course, a two-tailed test. Two-tailed test means rejection of 80 will fall in both tails. Okay, so the distribution we will use is chi-square distribution. And this distribution looks like this. Okay, so this is, of course, this is a chi-square distribution. My degrees of freedom is n minus 1, which is 24, as shown before. Okay, and my two rejection region, this area is alpha by 2 area. This is where we will reject H0. And the other will be in the, so this is the rejection region in the left tail. This is the rejection region in the upper tail. Okay. So this is also area is alpha by 2. Okay. So if I move up a little bit, so this is the chi-square distribution. So chi-squares are always indicated by the area to the right. Now the total area under the curve is 1. From that, if I take out alpha by 2 in the left. So the area left on the right of this critical value, so this is the critical chi-square on the left, is chi-square. I take out alpha by 2 from the total area. So the area to the right of this critical value is chi-square 1 minus alpha by 2. So this is critical value. This is also critical. And this will be indicated by chi-square. Area to the right of it is alpha by 2. So my goal, find chi-square 1 minus alpha by 2 and chi-square alpha by 2 for degrees of freedom 24. Now, alpha by 2 is 0.025. So so 1 minus alpha by 2 is equal to 1 minus 0.025 is 0.975. So I have to find out chi-square 0.975 area to the right of the critical chi-square and chi-square alpha by 2, which is 0.025 for df is equal to 24. Now the question is, how will I achieve that? Okay, so let's stop share this screen and go to another screen. Okay, okay, let's share the chi-square table. Did I pull out the chi-square table? Let me check on that. Okay, maybe not. So I have to go to the table. Let me see, I may have pulled it out here. So this is the one I want to share. So let me go back to my Zoom meeting and share this chi-square table with you. Okay, so this is the table we are going to use. My degrees of freedom is 24. So the first column is degrees of freedom 24. I'm looking for 24. And then I'm looking for chi-square 0.975, which is the third column. So I draw the horizontal line through 24 and uh, vertical line through chi-square 0.975. So they intersect. So let me make a note of it. Chi-square 0.975 for 24 degrees of freedom is equal to 13.848. Also, I'm looking for chi-square 0.025. So I go on 24 and 0.025 is a third from the right. So 24 and 0.025 is 39.364. And chi-square 0.025 is 39.24 and the third column is 39.646. So these are my critical values. Now, let me go back to my layers. Okay, and so if I reduce this a little bit, okay, so my chi-square from the table, chi-square 0.975 is equal to 13.848, and with 24 degrees of freedom is 13.848. Okay, and chi-square 0.025 with 24 degrees of freedom is 39.646. So these are my critical values. Okay, so these two are my critical values. Maybe I'll do a better job if I erase this one. Let me write it again and do a better job so that there's no confusion. So critical values, I'll list the critical values. Okay. So critical values are chi-square 1 minus alpha by 2 is uh, 0.975, and of course my degrees of freedom is 24, is equal to, this is chi-square 1 minus alpha by 2, because alpha by 2 is 0.025. So chi-square 1 minus alpha by 2 is chi-square 0.975. And that critical value is 13.848. And the other critical value, chi-square alpha by 2, which is chi-square 0.025, is 39.646, is equal to 39.646. Okay. Now I have to calculate the test statistic. Okay. Okay. So calculate the test statistic. Okay. So calculate test statistic. Test statistic. Okay. Which is chi-square is equal to n minus 1 times s square divided by sigma 0 square. Okay. So this is the test statistic. This is a characteristic of the sample that we have collected. Characteristic of the sample. Okay. So let's create some space. And of course, sigma 0 square is the value in the null hypothesis. In the null hypothesis. Okay. So my chi-square then becomes n is 25 minus 1 times s square. So I may have to go up to look for s value. Standard deviation s is equal to 8. Okay. So times 8 square divided by value in the null hypothesis is 15 square. So this is 24, 8 square is 64, divided by 15 square is 225. And that is equal to, let's do the calculation, 24 multiplied by 64 divided by 225. And the answer is 6.826. Okay. So our critical values are 13.848 and 39.646. Okay. So we can move up a little bit. Also reduce the size and we can move up. Okay. Since test statistic I square is 6.826 is less than I square 1 minus alpha by 2, which is, remember, equal to 13.848. That is, it's on the left of 13.848 on the horizontal axis. Decision, it falls in the rejection region. Decision is reject 80. Okay, so decision is reject 80. Okay, so if the decision is reject 80, then what is the conclusion? So conclusion is conclusion at alpha is equal to 0.05, there is enough evidence to support HA, the alternate hypothesis, because we have rejected the null hypothesis, which states, so if I move up, the alternate hypothesis states that sigma is not equal to 15. So sigma is not equal to 15. Okay, so the decision is reject 80. Conclusion is there is enough evidence. There is enough evidence at alpha equal to 0.05 to support the alternate hypothesis. Okay, so let me summarize what I did. Okay, so we will start from the very beginning. This may be a little offbeat problem, so let's read the problem. Scores on an IQ test are normally distributed. A sample of 25 IQ scores had standard deviation S is equal to 8. The developer of the test claims that the population standard deviation is sigma equal to 15. Do the sample data provide enough evidence to contradict this claim? So my null hypothesis is what the developer claims, sigma is equal to 15. Now the alternate hypothesis cannot be greater than or less than because they have not specified that. So the best bet for the alternate hypothesis is sigma not equal to 15. Our n is 25, so degrees of freedom is n minus 1 is 25 minus 1 is 24. Our level of significance is 0.05, which is alpha. That is the maximum probability of making type 1 error. You ask what is type 1 error? Reject 80 when it is true. That is, in reality, we should not have rejected 80, but anyways, we are rejecting 80 and making a wrong decision. So alpha by 2 is 0.05 divided by 2 is 0.025. Since the alternate hypothesis contains not equal to, it is a two-tail test. So we draw or we sketch the chi-square distribution for degrees of freedom 24. Area in the left tail, area of rejection in the left tail is shaded area, which is alpha by 2. Now, the chi-square, the critical value to the left of which in the left tail area is alpha by 2, but chi-squares are indicated by the area to the right of it. So in this case, because the left tail is alpha by 2, area to the right of this critical value on the horizontal axis is chi-square 1 minus alpha by 2. What about on the right tail? The right tail area is also alpha by 2. So area for that critical value of chi-square to the right of it is chi-square alpha by 2. So remember, chi-squares are indicated by the area to the right under the chi-square curve. So one critical value is chi-square 1 minus alpha by 2. The other critical is chi-square alpha by 2. Okay. So our alpha by 2 is 0.025. 1 minus alpha by 2 is 0.1 minus 0.025, which is 0.975. So we have to find chi-squared 0.975 and chi-squared 0.025. So we go to the critical values table. The first column is degrees of freedom. That should be 24. So we select degrees of freedom as 24, draw a horizontal line, and then a vertical line through the top row where the areas are given is 0.975. And that critical value, the first critical value on the left is 13.848. Similarly, we draw the horizontal line through degrees of freedom 24, and on the extreme right in the top row, where the area is just 0.025, I draw a vertical line and they intersect at 39.646. So these are the two critical values. So if we were to calculate a test statistic which is less than 13.848, or if the test statistic is greater than 39.646, then we'll reject the null hypothesis. So the test statistic is given by the formula chi-square is equal to n minus 1 s square divided by sigma 0 square. So chi-square test statistic is equal to 25 sample size minus 1 times sample standard deviation given in the problem statement is 8 square, divided by sigma 0 square, that is the value in the null hypothesis, which is 15 square. Okay. So we do the calculation, the chi-square comes out as 6.826. Okay. Since the test statistic chi-square is 6.826 is less than chi-square 1 minus alpha by 2, which is 13.848, it falls in the left tail in the rejection region of H0. The shaded regions in the chi-square distributions are where we reject the null hypothesis. So the decision is reject H0. If we reject H0, then the conclusion is at alpha equal to 0.05, there is enough evidence to support the alternate sigma is not equal to 15. I will stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up, a big thumbs up. I really appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I come back every day with new problem, new solutions. So please do not forget to check me out tomorrow. Thanks for watching. Have a nice day. Take care. See you later.